Hello there. We shall be having a detailed look at the solutions for your first CET test, especially those questions from motion in a straight line. We'll begin with the question number 4, but before beginning the video, a request to document all approaches and revise approaches regularly so that you will be in the flow or you can handle any problem at any given instant of time. So here we begin. The fourth question. Acceleration is given as a function of time. So that is one of the basic varieties of kinematics where velocities, positions, accelerations will be given at function of time, and you will be asked to find the other kinematic quantities. So the relevant discussion would be about this flow chart which we had drawn on the board a lot many days ago at the very beginning of our bridge course. So here we go. Um, to find velocity from a position, we differentiate the position. To find acceleration from velocity, we differentiate velocity. To find velocity from acceleration, we do the integration process. From velocity to position again, we do the integration process. That's all you need to attack such questions. A equal to 60 plus 5. So I would simply do it as dv is equal to 6t plus 5 dt. The most essential step comes over here, which you neglect. It is the initial conditions. Here they have given the point is initially at rest. Where does it matter? It matters when we introduce a serpent, the integral sign. The integral sign always rises from the initial condition and bites the final condition. The initial condition is speed is 0 at t equal to 0. Time is always 0. And the final time asked is 1 in the question. And we also initially we have to check what value is that. It is 0, right? And then some general value v. Well, once we do the operation, we say it is v is equal to, and then we take it as 6 times t square by 2 plus 5t. This whole thing between 0 to 1. In the place of t, we first put 1. So that would be like 3 plus 5. And then you'd be subtracting 0. You put 0 there, you will be getting a big 0. So you found out the speed. This is what most of you do, right? But unfortunately, our question will not progress further. The reason is they have asked the distance, but you have found the velocity at the end of, you know, 1 second. So yeah, you have done it right, but we can tweak it better. We can put instead of 1, you put a general value of t. Instead of 1, you put a general value of t, and then you calculate. We get v is equal to 3t square plus 5t, right? And then put v as once more dx by dt. Remember, wherever you introduce a serpent, there you need to see the initial conditions. The initial condition is it starts from the origin. So we say v equal to 0, x equal to 0 are the initial conditions. So here on, we take dx by dt is 3t square plus 5t, isn't it? You take the dt to the side, it would be integral dx is integral 3t square plus 5t dt, and then x begins from 0, very important, and then the general value of x. But you see, you need to find the distance at 1 second. So here we put the upper limit as 1 and not in the before integration. So very general mistake performed by many of us when we initially get to know this topic is we find numerical values in the intermediate stage of integration. For example, if you have to integrate 2 times, you will integrate 1 time, and then you find some numerical value and put this for the second integration. This should strictly not be done. You should not do this. Instead, what you should do is you should substitute the numerical values given in the question only after the second step. Here, the second stage is finding the distance. So such small things require utmost conceptual clarity, and here it is. So you do this operation, you do the integration, and you will find out the value to be around 3.5 meters. So you find out the value to be around 3.5 meters. So this is just a golden rule. This video is going to be about the approaches, the details, the mathematical working will be mostly on you. So the approach is this, and wherever you see integration, we remember the golden rule. Integral of t power n dt is always a t power n plus 1 by n plus 1. That's it. You don't need any other thing to solve the question. Hence, we treat the question number 4 to be solved. So we have solved the question number 4. And now question number 5. Uh, this is regarding velocity time relation, and they're asking a distance. Immediately, most of us think that, oh, we have been given velocity, we are being asked to find the distance. Sir, shouldn't we integrate? So that's what we did in the last question. In the last question, we integrated acceleration 2 times to get the distance. So shouldn't we do the same? The answer is no. There is a better time economical approach than you simply doing this. And that would always be the graphical approach. Wherever possible, try to plot the graph of the relation. Here they have given V is equal to mod of t minus 2, right? How can I relate V, t, and distance? Well, other than the calculus relation, I know that the area under VT graph will give my desired distance. So here we go. We draw the graph. The graph of mod of t minus 2 looks like this. I would draw it in a different color. Mod of t minus 2 looks like this, where the vertex of the V, the victory sign, is over here, and it is 2. Now, how to further find out the distance? They're asking the distance covered till 4 seconds. You see, the distance covered till the 4 second is, it covers the distance at what time? At 4 seconds. So what we do is we find the area of this graph till t equal to 4 seconds. Okay. To find the area, I see it as a combination of two triangles. Then what to do? Area of a triangle you can easily get if you know the height. How will you find the height? That is where this relation becomes useful. Use the relation. At This is a VT graph. At t equal to 0, what is the speed? At t equal to 0, the speed is 2. You put 0. 0 minus 2 is minus 2. Modulus of minus 2 is 2. Similarly, at t equal to 4, you put t equal to 4 over here. 4 minus 2 is 2. Mod of 2 is again 2. So you know the height of this triangle is 2. You know the height of this triangle is also 2. Now go forth and find the total area. That would be half into 2 into 2 plus half into 2 into 2, right? So that would be the thing, isn't it? So you put 4, you put the necessary things over here, and you will find the total area. Once you find the total area, that is it. That is our question, right? That is what we need to find out for the question. So here we are. We have solved the fifth question also. Whenever you find velocity distance, velocity time relation, instead of thinking of integrating, always give a thought for a graphical approach. Couple of reasons. One, here they have put the, it covers a distance of whatever you get by calculus approach. You see, whatever you get by this dx by dt, and you get the corresponding value of x and so on. That is not um, that is not distance, that it is displacement. So calculus always gives displacement, whereas graph can give displacement as well as the distance. Bear this important point in the mind, right? So whenever it is distance asked, try to trigger your mind to plot a graph and find the area. If it's acceleration asked, to find the slope of the graph and you will have the acceleration. So that is question number 5. And we move on to question number 6. This is a pretty involved question, I can say. They have given acceleration velocity graph, right? Velocity is as velocity is increasing, acceleration is also increasing, and they're asking the slope. You have no other way than to involve algebra, than to involve math as much as possible. So I have to first write this graph in a mathematical form. That is A equal to KV, Y equal to MX. So it is a straight lines concept, Y equal to MX, so A equal to KV. But they're asking the slope of velocity displacement, right? Somehow I need to bring in V and an X. I need to bring V and X graph given A equal to KV. Now, how do I do that? So how do we find the um, slope of velocity displacement? How to bring in Vx given AV? The only relation I see is given A to find something about Vx, we can always use A equal to V dV by dx. A equal to V dV by dx. If I put A as V dV by dx, you can see V is cancelling from both sides, and we are getting dV is equal to K dx, right? Once we have dV equal to K dx, I will bring on the serpent and I can say V is equal to Kx. So what does this tell? This tells that the slope of velocity displacement curve, which is V versus X, it is same as K. So what should happen? K is a constant, isn't it? So A equal to KV is V dV by dx. And then again, we get relation between V and X. We see V and X are depending linearly on each other with the same slope as acceleration and velocity. So here the K is slope, here also K is slope. So this is also a straight line. Slope of a straight line is always a constant. So thereby we have done this. A very tricky question. It is on the level of JEE main. Now, question number 7. In the question number 7, it is mentioned in all modules and all reference books about this average speed, average velocity of the particle, etc. Here they have given half the distance with speed of 3 meter per second. Other half the distance is covered in two equal time intervals with 4.5 and 7.5 meter per second. The best way to deal with all these things is if they have given half the distance, right? Always go for 2 meters. Let the total distance be 2 meters. Reason, because half of two is just one. So I can just say the first half distance is 1 meter, the next half distance is 1 meter. the the second half of 1 meter is covered in again two equal time intervals. So let it cover some distance with the t, other distance also with the t. In the first half, it is being covered with 4.5 meter per second. The second half, it is 7.5 meter per second. All right. Now, they're asking average speed. How to go forth for the average speed? Average speed is total distance by total time. So average speed can be written as a total distance, which is 2 upon total time. What is the time taken to cover the first half of the distance? It is going with 3 meter per second. We know that the speed is the age-old formula, right? You divide the distance with time and you get the speed. So what is time? Distance by speed. Distance is 1, speed is 3, so it should be 1 by 3 plus. What is the total time taken to cover the next 1 meter? 2t, because t plus t, 2t. I don't know anything about t. How to get information about t? Well, we know the distance covered in the first half t is speed in the first half multiplied with the t. So 4.5 t is the distance covered in the first half. In the second half also, it is 7.5 t. That's the distance covered. So the total distance covered would be 7.5 plus 4.5, which gives you 12 t. Total distance covered is 1 meter. So I get to know that the time is t equal to 1 by 12 seconds or units. But I don't need t as such, I need 2t. So 2 into 1 by 12. I put t as 1 by 12 over here. I get the, you know, answer. So the thing to be borne in mind is there have been cases where there are formulas to attack the question. But instead of the formulas, you can always remember the formula for more worthy questions, not these. These can be approached with numerically simpler way just by tweaking the numbers. If they say half the distance, you go for a total distance as 2 meters. If they say half the time, you go for the total time as 2 seconds, and so on, so forth. So that is the seventh question. Now coming on to the eighth question, question number eight. The distance covered by body falling freely under gravity in the first, second, and third. This is based on the Galileo's law of distances. So it is always found that in the consecutive seconds, equal time interval, the distance covered by a body falling freely under gravity is always in the ratio of successive odd numbers. So hence, the right answer should be 1 is to 3 is to 5. Right? It may be first minute, and third minute, or first second, 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 and a third second, so on and so forth. In the consecutive equal time intervals, the distance covered will always be the ratio of odd numbers. Cool. So with that, we go to question number 9. In the question number 9, it is rather something for you should tackle with just a figure. The figure would be that of a circular track. You see, there is a circular track. The radius is r. Let the athlete begin at this position. He completes one round in 40 seconds, right? What will be his displacement at the end of 2 minutes 20 seconds? 2 minutes 20 seconds is nothing but 140 seconds. 140 seconds means, how can I express the time? You see, he takes 40 to complete one round, 40 another second, so totally 80 seconds, 40 another second, totally 120, keep a count. Now in the 20 seconds, he will just complete half a circle, right? To complete a full circle, he needs 40. To complete half a circle, he needs 20. So 2 minutes 20 seconds can be visualized as 40 plus 40 plus 40 plus 20. So at the end of 2 minutes 20 seconds, he is on the opposite end, diametrically opposite position. So what is the displacement? Displacement is the distance between the initial and final position. It's the diameter, so it should be 2r. Cool. So this is something which you needn't use pen and paper at all, right? Now we shall go to question number 10. 10 is rather interesting. Well, if the round trip, you see the round trip means initial and final position both are same. If initial and final positions both are same, then definitely displacement has to be zero. You have a look at the honorable options. In honorable options, we have displacement zero only in D and A. So I can say B and C are gone, eliminated. Now between A and D, I need the average speed. Average speed means the total distance by, total time. Total distance has this radius, and quarter of a circle. Quarter of a circle circumference is 2 pi r. The whole circle is 2 pi r. So one fourth of a circle will be one fourth of 2 pi r, which is pi r by 2. Right? Now you see that this distance is pi r by 2. So definitely the when I divide pi by some time, maybe 10 minutes, 20 minutes, whatever it is, when I divide pi by some time, I can never get 1. I'll always get a decimal. Therefore, 10 goes with D. Minimum working, it is just you need to understand the ways to approximate and save time with CET, right? So 1 minute per question. Now we go to question number 11. A body moving with uniform acceleration describes 40 meters the first 5 seconds, 65 meters the next 5 seconds. Its initial velocity will be. Right. So, in such questions, you should assume that the body is not at rest initially because there is no mention of rest anywhere, right? So what is the ideal way to tackle this question? So we now take question number 11 over here, right? So here we see that it covers some 65 meters, say, in the first 5 seconds, and say 40 meters in the next 5 seconds. The keyword is next. And then they are asking what is initial velocity. And the keyword is they say that acceleration is uniform. Whenever and wherever you see acceleration as a uniform acceleration, there you can leap with joy and put v equal to u plus at and then s equal to ut plus half at square and whatnot. The third equation too. All these are valid only if acceleration is constant. So here we go. Now we can put that. Let us say initial velocity is u. Then the first 5 seconds, s is 65. So 65 is equal to 5u plus half a into 5 square, which is 25. Everybody does this correct. They mess up in the next thing. See, they have told next 5 seconds, right? So we need to measure time from the instant the time started with t equal to 0. If you measure time from t equal to 0, the next 5 seconds means the total would be t will be 10 seconds. And what would be the total displacement? Total displacement will be 65 plus 40, which is 105. People usually substitute 40 as s and t as 5. No, that's not to be done. Because time usually started from this instant, t equal to 0, then it became t equal to 5. Now, after 5 seconds, it will become t equal to 10. So you put t as 10. So you have 10u plus a half a into 100. You get two equations. One having two equations having two variables. One is u, other is a. Using your 10th standard linear equations strategy, you can eliminate and find out the value of u. So there goes the question. That is as easy as it can get. But I also have warned you of the conceptual niggles, right? Now that is question number 11. Now question number 12. Okay. What is the average velocity of the particle? Whenever average velocity comes, you need to be cautious because velocity depends on displacement or not distance. And displacement depends on position. Position can either be completely forward, completely backward, or a mixture of going forward and coming backward. It is, you need to search the questions for these words. Here they have given the particle moves for 20 seconds with velocity 3 meter per second, 4 meter per second, 5 meter per second without mentioning any direction. So we assume that it is moving in the same direction for all times. If it moves in different directions, then definitely the question would have been more fun. So how to find average velocity? Average velocity is a total displacement by total time. Displacement can be found as sum of displacements in the individual phases. Sum of displacements in the individual phases. Displacement is velocity into time. So displacement in the first phase is 3 into 20, which is 60. Then 4 into 20, which is 80 plus 5 into 20, which is 100 by the total time. 20, 20, 20, totally 60. So 180 plus 60 is 240, 240 by 60 is 4. So we can say it is 4 meter per second. Many of your competitors across India solve such questions orally. I'm also giving you further extensions where the direction of motion can change, right? So the 12th question can be done orally. It is displacement by time concept. Displacement is sum of individual displacement. Now, question number 13. The question number 13, again, constant deceleration is the keyword. Here is where we can make, you know, use of kinematic equations. I had to mention this earlier in the video. Looking at a question, please do not always try to apply V equal to U plus AT, S equal to UD plus half AT square and so on, because it is a terms and conditions apply for those. We know it is applicable only for constant acceleration. So beware before you use V equal to U plus AT for all such questions. For example, the fifth question which we dealt and this question which we dealt, do not think of V equal to U plus AT at all. So, yeah, now we will look at the 13th question. In the 13th question, initial speed is given as 72 kilometer per hour, which would mean, and look at the other units, meters and second. If it is meters and second, we shall always convert kilometer per hour to meter per second. Now, how to convert kilometer per hour to meter per second? Again, we have a look at the conversion factor. In the conversion, it would be question number 13. We will say converting kilometer per hour to meter per second would be simply multiply by 5 by 18, whatever speed is given. So 72 into 5 by 18 would be U will be 20 meter per second, right? And then there is a barrier, it seems. The barrier is 20 meters. So there is actually a sort of a car, and then at 20 meters there is a giant looking wall. This idiot was traveling with 20 meter per second speed. He will slam the brakes hard, right? And then you need to find and he hits the barrier 2 seconds later. And he hits this t equal to 2 seconds later. And you need to find what is the braking acceleration, with what acceleration did he apply the brake. So you have identified the variables. Now the time is for relating them. The strategy ICU. Remember, have identified. Now time to examine and evaluate. S is given, sign convention. So S is 20, U is also 20, and then plus half AT square. T is given as 2. Substitute, and you will find the value of A. Few students, though, they think very, in terms of humanity, and they see that the driver has to slam the brakes in such a way that he comes to a rest at the barrier, right? This is a desirable condition, but not a necessary condition. He may not come to rest at the barrier. So please be beware of that. Don't put V equal to 0 without the question explicitly stating it. Always it is useful to relate the variables using the conditions given only. Don't assume anything and put in the equation. So that is question number 13 for you. Now, question number 14. If a body loses half of its velocity on penetrating 3 centimeters in a wooden block, by how much will it penetrate more before coming to rest? All these block questions and bullet questions, we can treat it in like a journey, right? Initially, it had some speed u, and it covered some distance x1, and then it became u by 2. How much more distance it will cover finally before coming to rest? X1 for us is given as 3 centimeters. In all bullet block questions, BB, we call it, bullet block questions, we always assume acceleration is constant, or the bullet is experiencing a constant force from the wooden block, a resistance force. If force is constant, acceleration has to be constant, and there is a savior. If acceleration is constant, we can apply all the three equations of motion. So how to go for it? We consider just this and say, and use v square equal to u square plus 2as, because final velocity, initial velocity, displacement is given. The only equation which ties all this is this. For the first half, v is u by 2 and u becomes u. Now we consider the second half and s is x1. The second half के लिए v will become 0, u will be nothing but u by 2, and we need to find x2, right? This is for this term. Both the equations, if you write equation for this and this, what turns out to be common is a. A is same in both. So you can eliminate a and find out x2 in terms of x1, x2 in terms of x1. So that is one way. The other way which JE people try to use is trying to plot a VT graph for this, an alternate approach. In a VT graph, what would happen is initially the bullet had, u speed. After traveling certain distance, 3 meters, the speed became u by 2. After traveling how much would the speed ultimately become 0? They convert the question given in terms of graph itself. VT graph becomes very convenient because acceleration is constant, so it is a straight line. Not only that, it has the velocity is decreasing, it's slowing down. So the straight line can't be like this, instead it has to be like this. Cool. So yeah, this is mostly it. Given these variables, find the value of x. You can use similarity, you can use trigonometry and arrive at a value of x from 3. This approach is far more easier than tackling with the individual algebraic equation. So here it is. You have two approaches, the algebraic and the graphical. That would be, say, question number 14, right? Now, question number 15. In question number 15, uniform acceleration, alarms go dun 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 dun. It is v equal to u plus 80 and all can be applicable. Distance of 65 in the 5th second and 105 meters in the 9th second. How far you have to go in 20th second? Wherever you see nth second, there we go with Sn equal to u plus a by 2 into 2n minus 1. No doubts about it. And unless stated, do not assume this as 0. Do not assume u as 0. It may be a variable. So they have given two values of distances. So it will be like 65 equal to u plus a by 2 into n value is 5 first. So 2 into 5 minus 1 is 9. And then 105 is equal to u plus a by 2 into put the value of n as 9. So here we get 17. Two equations and say this is a, right? So two variables, two equations, two variables. You find the variable u and a, but that's not it. The question is further complicated. How far will it go in 20 seconds? Remember, they're not asking 20th second. So don't be under the misunderstanding that you will use once again SN formula. They're not asking 20th, but instead 20. So we'll use S is equal to ut plus half 80 square, put t as 20. A and u you shall get from solving the system of, I mean, you can solve these two equations, get the value of u and a. So that is question number 15. Question 16, another a graphical thing. They have given VT graphs everywhere. It starts from rest. So I can eliminate C and D at first because at t equal to 0, the velocity is not 0, right? But they're selling it is from rest. So either it is A or B. Then uniform acceleration, we have done this n times. Uniform acceleration means the graph will be a straight line. What graph? VT graph. So it shall be this. Now, this graph is also quite possible for uniform acceleration, but it is not of VT, but instead it would be XT. For an XT graph, this can be quite possible. XT graph with uniform negative acceleration, we can have this graph. But VT graph can't be this. Instead, it has to be a straight. So that is question number 16. Now, question number 17. 17 is a cliche question. Many times it has been discussed in the class also. The maximum speed of the particle, AT. So, area under AT graph will always give you change in velocity. So, wherever the area is maximum, their change will be maximum. Change is nothing but final velocity minus initial velocity, which is rest, so 0. So what is the area? Area is half into base into height, half into 10 into 11. So that would be 55. So the maximum speed of the particle will be at this instant, because at this instant itself, the area covered is maximum. At any distance, other time if I take, the area covered will be less compared to this, right? So we got the value V as 55. And now we go to 18. This is a CET PYQ as well. Given the displacement time graph, how will I find their velocities? Interesting. We know the slope of xt. Slope of xt gives you velocity. Slope कैसे find करते हैं? You just put tan theta. So the ratio of V1 is to V2 is 1 makes 45, other makes 30. Tan 45 to tan 30, 1 is to 1 by root 3. So the option should have 1 is to 1 by root 3 if I'm taking ratio of 1 is to 2. But I can't see any relevant option. So they must have taken 2 is to 1. If it is 2 is to 1, this by this, I mean, velocity of 2 by velocity of 1, the option will be A. So it may not happen that your thought process aligns with the examiner's thought process. You just need to be careful. Instead of panicking and seeing answer nahi hai options mein, you can think in a different way and say that 1 is to 2 if it's not given, 2 is to 1 is given, which the most relevant one is 1 is to 3. Right. Question number 19 has, some problem. The problem is the distance east in meters, and it is being given as a distance and the graph goes below. Right. Here we wonder. We know that distance can't ever be negative. You see, distance is going in a negative y direction. It can't happen. And then they are telling average speed for the whole time interval is what being asked. So here we, think average speed and have weirdly mentioned distance east. You see, so if I say the initially the boy's home is at this point, always the reference is given in the east direction, which is this is the east direction. So they have told the distance covered only here. What is the meaning if the distance east becomes negative? Right? What is the meaning if distance east becomes negative? It means the boy came back to home and he's going in the west direction, right? So that is how we interpret this. If this is going in a negative thing, it means that it is not distance they are particularly asking, it's distance the particular direction. So it is position or displacement is what they're talking about. The boy started from his home, and at this time you can see the distance is 0, east is 0, which means he came back to his home and he started moving towards west. They're asking the average speed. Well, to find the average speed, you need to know the total distance traveled. Speed है ना? So you need to know the total distance traveled and divide it by the total time taken. Total distance traveled by the total time taken. Now, what is the total distance traveled by the person over here? You can break the graph like this. Cool. So at the end of 5 minutes, the person is at 40 meters each. So he traveled 40 meters in 5 minutes. Then he didn't move at all, because at every time instant between 5 to 10, he is at the same distance, right? He didn't move. Now, between 10 to 15, again he covered 40 meters. Why 40? Because the distance initially he was at 40, now he's at 0, so he covered 40 meters. Again, he took some time, and then again you can divide this ulta looking triangle into two halves. You need to find this height. What is its height? equal to that height is again 20. So he traveled 20 and 20. Okay. So total distance traveled would be 40 plus 40 plus 20 plus 20, around 120. And then you divide by the total time. This should have been the approach. But unfortunately, that could not be interpreted by beginners, because distance east conveys the meaning that distance should always be positive and not negative. But in fact, they are talking about displacement, and that is where we have to be clear about. So just one detailed thing. So here is where we went like this. This is 40. This is also 40. I found out this is 20, right? So this is distance east versus time. So in 5 minutes, that person covered 40 meters. Next 5 minutes, he didn't do anything, right? And then he came back. He walked back. Backwards, he's walking. So he covered another 40. So 40 plus 40, 80. And again, he covered in the west direction this distance, which is 20. Again, he came back 20. So total distance covered is 40, 40, 20, 20. Total distance is, 120 meters. You look at the total time taken. Total time taken is the easiest thing. Total time taken is around 19, you can say, right? So you can put the values and get the result. So that is how we tackle such questions. Very tricky is speed should be distance. You should be able to visualize what is happening. You can visualize what is happening only if you convert this to literally walking situation. Initially, the guy was here. He walked 40 meters in how many minutes? 5 minutes. He stayed there for 5 more minutes. Then he came back another 40 meters with some speed, right? And consuming some time. He went this way 20 meters, right? And then again, he came back to the same position because distance east finally is 0. So he started at the origin, he did to and fro, came back to the origin only. So this is how you convert a graph to a living reality. This should be done. Now, definitely not a CET question anyway, but for further examinations, it's better if you know this. Question number 20. A particle moving a straight line with blah, 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 constant acceleration, directed along the direction of instantaneous velocity. Which of the following statements are false? Trigger word, false. Don't find the correct option, find the wrong option. A particle may reverse the direction of the motion. Yes. Okay. It shall reverse the direction of the shall it or shall it not is the question. The particle will reverse the direction. Imagine, when will you reverse the direction? Only if you are running with some speed v, slam the brakes hard, acceleration in the other direction, slowly you'll come to rest, and then take your car back, right? Only when velocity and acceleration are opposite in directions, then there's a possibility of particle reversing the direction of motion. So definitely the particle won't reverse the direction of motion. So first one is false. Should we stop? No, because there is all of the above also. We need to check at least one more option before driving to the conclusion. The magnitude of average velocity is less than the average speed. Not really, because imagine a particle started from over here. It always moves in a direction, in a single direction, without changing its, without reversing the direction, right? So the distance covered will be x, and displacement is also x. So x is distance, x is also displacement. So average velocity and average speed will always be numerically identical. That much I can say for sure. Average velocity and average speed will always be identical, because the distance and the displacement will be the same. Only if the object reverses the direction of motion, then displacement will be lesser than the distance, and average velocity will become lesser than average speed, right? Average speed, correct? So that's not the case anyway. So this statement is also false. So if two statements are false, I won't look at even B. I can say definitely D is right answer because all the statements are false, right? So not a JE, not a CET question again, a JE plus level. A 21st question we shall go. In the 21st, what is a displacement and what is a distance traveled in a VT graph? Well, if you areas above x-axis is positive and area below x-axis is negative, if you follow this convention, whatever you get, that shall be displacement. If you don't consider the sign convention, whatever you get, it shall be distance. For example, area in black is positive, whereas area in red is negative. If you add the black area, subtract the red area, whatever you get is displacement. So we see displacement should be lesser than the distance over here because the total area is always lesser than this subtracted area. So in which of the option is displacement lesser than the distance? Displacement is lesser than the distance only in say A, right? And that's it. In all other cases, it is literally the same. So I can say A must be the answer. I didn't calculate much. I just use the concept displacement lesser than distance. 22, their options are not so clear. They're asking the sign of accelerations of the particle. Given xt graph. Look, the funda is this. Given any xt graph, if acceleration is asked, we just find how the slope of the points are doing, right? Slope. We take any 2 points on the curve and see how the slope doing. For example, if I take this segment OA, right, I can see that the slope is decreasing. That slope is decreasing. Slope is decreasing means velocity is decreasing. If velocity is decreasing, that would mean acceleration is negative in OA. If I want to find how is acceleration in CD, again I take 2 points and compare the slope. Here I can see that slope is actually increasing in CD. Therefore, velocity is increasing, therefore acceleration is positive. So that's how you relate accelerations to xt graph by considering whether slopes are increasing or slopes are decreasing. Question number 23. In question 23, of course, this is from the physical world chapter. Here they have given a net nuclear force, net nuclear force. So they have not mentioned electrostatic force. So all the entities inside the nucleus, regardless of protons or neutrons, will experience the same forces because nuclear force is independent of charge. That is one of a very beautiful facts about this. So if I have a neutron and a proton at some distance, it will have the same force of attraction as a proton and proton at some distance. Of course, ignoring electrostatic repulsion. So the right answer should be B because force is independent of the charge. It doesn't matter whether the particle is neutral or whether the particle is charged. Now, a force between two protons is same as force between a proton and a neutron. This has been covered in the previous one. If you, the nature of the force should be strong nuclear force. Strong nuclear force is always acting between a proton-proton or a proton and a neutron. Now we go to question number 25. In question number 25, which of these possibly represent? You should be careful. They're asking for the correct choice, not for the wrong choice. Possibly. The motion should be possible. It's an NCRT based question. I can reject the first graph, third graph, and the fourth graph simply because time is going on a negative axis. The right option is only B. 25 goes with B. Now, moving on to question number 26. A body starts from rest, moves with constant acceleration for t seconds. It travels x1 in first half and x2 in the next half of time. Then what? Well, here is where graph approach would do you very good. It starts from rest, so V0 initially. It is accelerating, so a slope, the graph is a straight line. Cool. Okay. It travels with constant acceleration for t seconds. In the first half of time means at t by 2, the distance covered is x1. So the area under Vt graph, this is x1. In the next half of time, in this t by 2, the distance covered, I will highlight with a different color perhaps. So this distance, this area is x2. How will you relate x1 and x2? Areas, right? So let us first find the total area. Okay. What should be the total area of this uh, thing? The total area of this is half into base into height. Half into base of this into the height. That's the total distance. In that total distance, I can say that the area of the big triangle minus area of a small triangle will always give area x2. See, if I if I calculate the area of this triangle, subtract area of this, I shall be getting this trapezium wala area, right? So how to express area of the big triangle now? Cool. So here is where we think about similar triangle. We see that the big triangle is similar to the area of small triangle. From 10th standard, you can say area ratio, area 1 by area 2, is side of 1 square by side of 2 square. The only side I can compare is the base. The base of the big triangle is t, whereas the base of the small triangle is t by 2. So I can outrightly tell that area of big triangle is, you calculate the ratio, 4 times area of the small triangle. But what is the area of the small triangle? Area of small triangle is given as x1. So area of a big triangle is 4x1. 4x1. So I then say that if I subtract area of the smaller triangle from area of the bigger triangle, I should be getting the trapezium area. So x2 should be 3 times x1. We didn't use much of any motion equations over here. We have used similarity of class 10, area of triangles relationship, and so forth. Why could we do this question easily? Because the body starts from rest. So I can easily see that it converts to a very convenient triangle system. So 26 goes with 8. X2 is 3x1. Now coming to the famous drunkard question. Well, he takes 8 steps forward, 6 steps backward. Each step is 1 meter long and requires 1 second. And the pit is 18 meters away from the start. So I will sketch a drunkard. Not the best representation, but yeah, here is the pit. The distance is 18 meters. He's traveling 8 forward and 6 backward. Each step requires 1 minute, and then each step is 1 meter, 1 minute or a second. Let's just check. It is 1 second. Oh, he's not moving very slowly. 1 second. The logic is, you should just think about it. Let us say that he came to x equal to 10 somehow, going back and forth and all, he traveled 10 meters. From this position, if he travels 8 more meters, he will be straight into the pit. He won't have a chance to come 6 meters back at all. See this? If he covers 10, it is sure that in the next 8 steps he will fall into the pit. So first let us calculate how much time he will take to cover 10 meters. 8 steps forward, 6 steps backward. So the net progress is always 2 steps. So he covers 2 meters in time taken to cover 8 steps is 8 seconds. Time taken to cover 6 steps is 6 seconds. Time does not subtract, time adds up. So he covers 2 meters in 14 seconds. So in how much distance will he cover? In how much time will he cover 10 meters? In 10 meters can be covered in 70 seconds. So he takes 70 seconds to come to 10 meters from where he was. Now he will walk 8 meters forward and he falls straight headlong into the pit. How much time will he take to cover 8 meters? Definitely 8 seconds. So the total time he takes to cover this much is 78 seconds. Okay. The one misconception in this question is people usually do this 2 steps forward, net progress. It means he covers 2 meters in 14 seconds. How much will he cover 18 meters in? No, you should not be doing this. Reason, uh, this is applicable if he reached 18 meters. This assumes that he reached 18 meters by going front of 18 and coming back. He took 8 steps forward of 18 and he came to 18, right? Because we need to complete a journey. Only then this 2 meters 14 seconds logic is applicable. He's not completing a journey. He completes a journey only if it is the first is 10 meters and the next 8 meters he goes into and lands on the vector. So that would be the drunkard question, the 27th one. A good one, because many of them would fall, not only a drunkard, even the students would fall into the pit of, you know, this doing this unitary method. 2 meters, 14 seconds, 18 meters, how much? You can't apply this logic because this is applicable only if you are considering 8 forward and 6 backward. This 6 backward will miss out for him because from the pit, he definitely can't travel 6 backward. So be careful for that. 28th question. The 28th question, it is a particle starts from rest and what is a relevant VT graph? Rest. So V should be 0. The only graph where V is 0 is this initially. Rest all has some non-zero, right? It travels, it moves at uniform acceleration. So yeah, speed is increasing. It remains constant for some time and then it slows down. So just like a hump in a road, exactly this is what happens in a hump in a road. To cross a hump, you first accelerate, travel at constant velocity, and then not to hit yourself hard on the road, you brake down, right? You apply brakes. It's exactly like a hump. 28 goes with C. Now, question number 29. For a particle, this is one of the toughest questions, challenging questions in the whole paper. For a particle moving along x-axis, mark the trigger incorrect, not the correct, but the incorrect. Well, everything is about x being positive and negative. So how about we sketching it? Right? First option, x is negative and becomes less negative. Let us say it was at -5, all right? And then it is becoming less negative. So it's now becoming -4, -3. So the particle is actually moving this way. Displacement is this way, which is positive. Displacement is positive. So average velocity is positive. So first option is right. What about the second option? If x is positive and increasing with time, let us say x is at 5 initially, +5, and it is increasing, it becoming 6, 7, so on, 8, so on. So the displacement is towards the right, again positive. So we say since displacement is positive, velocity is positive. So B is also correct. What about C part? Well, C is also right because velocity of the particle is always positive. Since it is always headed in the positive x direction, x is positive increasing with time, always in the positive x direction. It means it has always positive velocity due to sign convention. Anything pointing towards right is positive, left is negative, top is positive, bottom is negative. Sign convention. Even C is right. So by elimination, the only incorrect statement can be D. So 29 goes with D. Going forward to the 30th question. One of a good questions, a PYQ also. A ball is released from the top of a tower of height h. So this is the height h. It takes u equal to 0. It takes t time to reach the ground. What is the position of the ball from the ground at t by 3? Let us say at t by 3, it fell h1 distance from the top. Okay. We go with our um, the sign conventions method. Well, wherever the ball was dropped from, that shall be the origin. If that is the origin, sign conventions follow. So minus h is equal to u is 0 minus half g t square. For the h1, I can say minus h1 is equal to minus half g times t by 3 whole square, because it takes t by 3 to cover the h1 distance. Well, when I see this, h is equal to half gt square and h1 is equal to half gt square into 1 by 9. I split t by 3 whole square as t square into 1 by 9. Half gt square is h itself. So I say h1 is h by 9. So the distance it fell in t by 3 is 1/9 of the total height of the tower, right? But they are not asking this distance, mind you. They're asking height from the ground. They're being very clear. So they want this distance. If this is h by 9, if the total is h, then the other distance would be 8h by 9, right? So you need to be careful. The distance covered by the ball, if they ask, it will be h by 9. But height from the ground is a total height minus the distance covered by the ball, which shall be h, the total height minus h by 9. So totally it would be 8h by. So here is my, some tips to how you could have done the paper, the CET paper, especially the challenging questions in the paper were this distance to the east question. So this requires you, not a boy begins to walk, right? So it is not the boy. You should walk from the origin and see how it is going. You should feel the motion. As I told in the class, motion and emotions are both to be felt. You should feel the motion and then you can crack the question. So this is my take at the CET paper, your first CET paper. Anything above 10 or 15 in this paper means you have grasped the concept. So I thank you for your patience. If at all you have made till the end of the video, all the very best for the next exams to come up. Field physics, and let us do more physics. Take care and bye-bye.